Welcome to our deep dive into the fascinating world of sentiment analysis. We're using Python today.
Oh, very cool.
Yeah, and you sent us some really interesting stuff.
Right.
We've got some code and documentation,
Yes.
and even tab results for a Python module. It's called sentimentscores.py.
Catchy.
Yeah, and the really cool thing is this isn't just some theoretical project. This is a real working module.
Yeah, it's ready to go. You can use it.
So today we're going to take a deep dive into it and really explore how it uses 5 different models to understand sentiment.
The emotions behind the words.
Yeah, exactly. Exactly.
It's really amazing how much information is hidden in the tone of something that's written down.
Yeah.
And this module can unlock that. We're talking analyzing everything from financial reports
Well,
to
yeah.
social media posts. And you get these amazing insights.
It's so much more than just positive or negative.
Oh, yeah, absolutely. Way beyond
Yeah.
that.
This module, from what I've read so far, claims to be able to analyze sentiment in different domains like finance, law, science, all sorts of things.
That's right.
It even adjusts like which models it prioritizes based on what kind of text it's analyzing.
Yeah, that's a really cool feature. It uses what we call zero-shot classification to figure out, okay, what domain are we in?
Okay.
If it sees the words, stock prices
Right.
or quarterly earnings, it's like, I'm in the finance world. I better lean heavily on Finbert.
Makes sense.
That's our financial model.
So it's like instead of a one-size-fits-all approach, you've got a team of specialists.
Exactly. Yeah, it's like having a financial analyst and a general linguist. And we need a lawyer.
And they all have their expertise.
Exactly. So we've got Finbert for finance, Bert for general language, LegalBert for law, Cybert for scientific texts, and Vader for social media.
It's like a whole team working together.
Yeah, and that's actually a really good analogy because the documentation describes this module as offering advanced sentiment analysis and text embedding functionalities using multiple pre-trained language models, including Finbert, Bert, LegalBert, Cybert, and Vader.
That's a mouthful.
It is.
I'm really intrigued by this idea of text embeddings. It sounds like they've turned words into numbers, like numbers that represent meaning.
Yeah, that's right. It's not just looking at individual words, it's capturing the whole essence of the text.
The whole feeling.
Exactly. And it combines these embeddings as numerical representations from all 5 models.
Wow.
Again, using those, domain-specific weights.
So it really is like having this whole team of experts.
It is. You get a much richer understanding this way than any single model could on its own.
So we've got these 5 specialized models. They're working together. They adjust based on the text.
Yes.
Super powerful. But does it work in the real world? Like, how fast is it?
Oh, it's definitely fast. That was one of the things that really impressed me when I was looking at this. They really focused on performance.
Okay.
They've incorporated parallel processing so it can run multiple analyses at the same time.
Oh, okay. So it's like that team working together again.
Yeah. And they've also implemented this really cool caching mechanism. So basically, it stores previously calculated results, so it doesn't have to do the same work over and over again.
So if it sees something similar, it's like, I got this.
Exactly. And, the documentation actually highlights that. It says it optimizes processing by running tasks concurrently with Threadpool Executor and implements a caching mechanism to optimize repetitive analysis tasks.
Well, it really sounds like they've thought of everything. But the proof is in the pudding.
Of course.
You mentioned test data. What can you tell us about that?
Yeah, so they ran 2 types of tests. One with a hard-coded sentence and another with randomly generated sentences.
Okay.
The hard-coded one was the company stock is performing exceptionally well this quarter. And then the other one, they used a bunch of different sentences, but they all started with the company.
Interesting. And they ran these through the analysis how many times?
10,000 times each.
Wow. They really put it through its paces.
They did. And the findings are really interesting. They looked at average processing time, the variations in the sentiment scores, and how much the embeddings varied.
So it's not just that it works. They actually looked at how well it works.
Exactly.
Okay, I'm definitely intrigued. So we've got domain-specific analysis, 5 different models, super efficient processing,
Yes.
and they actually tested it in the real world.
Yeah.
Let's dive into those test results
I'd do it.
and see what they reveal about this module's performance.
Welcome back to our deep dive on sentiment analysis with Python.
Okay, so before we get to those test results,
Right.
I really want to understand how it all works.
Of course.
Like,
Yeah.
we talked about the models, the dynamic weighting,
Mhm.
but how does it actually turn text into a sentiment score
Right.
and an embedding?
Yeah. Well, the first step is actually pretty straightforward. It's pre-processing.
Okay.
So the module cleans up the text. It gets rid of any unnecessary characters, standardizes things like capitalization and spacing.
So it's making sure the text is ready to go before it goes to the analysis team.
Exactly. Yeah, we want to make sure we're focused on the real meaning of the words and not any kind of weird formatting or anything like that.
Okay, so it's cleaned up, and then what happens?
Then we get to that zero-shot classification
Okay.
we mentioned earlier. So the module has to figure out what kind of text it's dealing with, right?
Right.
Is it financial? Is it legal? Is it scientific?
Uh-huh.
It compares the text to a set of predefined domains and uses that to kind of make a decision.
Okay, and that's how it figures out,
It's exactly.
which of the 5 models to weight more heavily.
That's exactly right. That dynamic weight mapping, like we said before, makes sure the most relevant models are doing the most work.
Mm-hmm.
So if, for example, the text is about a company's, financial performance,
Right?
Finbert's analysis is going to be really important.
Vinbert's going to step up.
Finbert's going to be the star of the show.
Okay, so the text is prepped.
Yep.
It's categorized.
Yep.
And then sent to the specialists.
Yeah.
So then how do these models actually analyze sentiment?
Well, that's a great question. And they each have their own methods, right? So some, like Vader, use a lexicon-based approach. They compare the words in the text to, a dictionary of positive and negative terms.
Okay.
Others, like Bert and Finbert,
Yeah.
those are a lot more complex. They use deep learning algorithms to really analyze the text and make a prediction about its sentiment.
So it's almost like each model has its own way of reading and understanding the text.
Exactly. It's kind of like, they're all reading the same book, but they're all getting a slightly different interpretation.
Okay, that makes sense. So then how are those different individual analyses
Right.
from each model combined into one single sentiment score?
Well, they use what's called a weighted average.
Okay.
Again, taking those domain-specific weights into account. So that means that final sentiment score,
Yeah.
it reflects not just the average of what all 5 models think.
Okay.
It's more nuanced than that. It's based on, which models are considered most important for that specific text.
Okay, it's not just a simple average.
Nope, it's much smarter than that.
Okay, that makes a lot more sense. So we get the sentiment score.
Yep.
Now, what about those text embeddings? How are those created?
Okay, so those come from the deep learning models, Finbert, Bert, LegalBert, and Cybert.
Okay.
These models are really cool because they don't just output a sentiment score.
Yeah.
They also generate this vector of numbers called an embedding that represents the meaning of the text.
Okay, a vector of numbers.
Yeah.
So I'm picturing a line of numbers.
Think of it as a point in multidimensional space.
Whoa. Okay.
And each dimension of that space represents some aspect of meaning. So words that have similar meanings, they're going to cluster closer together in this space.
So the embedding is like a fingerprint
Yeah, that's a great way to put it.
of the text's meaning.
Right.
And then where it is in this meaning space
Right.
tells you about its relationship to other texts.
Exactly.
That is so cool.
It is really neat. And just like the sentiment scores, the module combines the embeddings from each model
Right.
using those domain-specific weights
Yeah.
to create a final embedding that represents, a really well-rounded understanding of what the text means.
So we're really capturing the whole essence of the text
Yes.
in these embeddings.
Exactly.
It's like getting 2 analyses for the price of 1.
It is. You get the sentiment and you get this deeper meaning representation.
So all of this complex analysis
Yeah.
must require a lot of computing power, right?
It would seem that way, but they've done a really good job of optimizing things.
Okay, good.
So one of their main strategies is parallel processing. Instead of analyzing the text with each model one at a time,
Uh-huh.
it runs them all at the same time. It's like a well-coordinated team.
So it's not waiting for one model to finish before it starts the next one.
Nope.
It's just doing it all at the same time.
All simultaneously.
That's amazing.
Using something called Thread Pool Executor.
Okay.
And then, of course, we've got that caching mechanism we talked about,
Yeah.
where it stores those previously calculated results.
Okay.
So if it encounters, similar text or even similar domain classifications,
Right.
it doesn't have to do all that work again. It can just pull those results from memory.
So it's like it's got this super organized filing
Yeah,
system.
right.
It's like, I've seen this before. I know where it is. I'll just grab it.
Exactly.
So all of these optimizations make a huge difference in terms of speed, right?
They absolutely do.
Okay.
And it's not just, a theory. The test results actually prove it.
Okay, so let's talk about the results.
Let's do it.
You mentioned they ran two types of tests. One with a hard-coded sentence,
Great.
and then one with randomly generated sentences.
Exactly.
So what exactly did they measure, and what did the results show? Okay, so let's get to those test results. We've been talking about this module, how it works, all the different models, the optimizations, but I'm ready for some evidence. What did these tests actually show about how this thing performs in the real world?
Well, they looked at a few key things. First, they wanted to see how consistent the module is. Would it give you the same answer every time?
Right. Yeah, that's important.
So they took that hard-coded sentence we talked about.
Yeah.
The company's stock is performing exceptionally well this quarter,
Oh,
and ran it through the analysis 10,000 times.
10,000 times. Seriously.
Yeah, no kidding. They wanted to really put it through its paces and see if it would hold up under pressure.
So did it. Did it give the same answer every time?
It did. It really did. The sentiment scores that it generated for that exact same sentence over and over again
Right.
were incredibly consistent. And even those text embeddings we talked about, those vectors that represent the meaning,
Yeah.
those showed very little variation. So basically, even when you give it the exact same input thousands of times,
Mm-hmm.
the module doesn't get confused or start giving you weird results. It's stable, it's reliable.
That's good to know.
Yeah, definitely.
So, okay, it's consistent, but what about speed? In the real world, we need results fast.
Well, that was another big focus of the tests, and the results were really impressive. I mean, the average processing time for each iteration was incredibly fast, much faster than I would have expected. And, a big part of that is thanks to all those parallel processing techniques and the caching that we discussed earlier.
So consistent, fast, sounds pretty good so far. But I mean, let's be real. In the real world, you're not going to be analyzing the same sentence 10,000 times.
Right, exactly. You're going to have all sorts of different texts thrown at you.
So how did it handle that kind of variation?
Well, that's where the second test comes in, the random sentence test. For this one, they actually used GPT-2, that powerful language model,
Yeah.
to generate 10,000 completely unique sentences, all starting with the company, giving them this huge range of topics and sentiments to work with.
So like a real world test, huh?
Yeah, like a mini universe of text to analyze. It's
Yes.
really cool. And the results show that it was able to analyze the sentiment of all these different sentences
Right.
accurately, generating meaningful scores and embeddings for each one.
So not only is it fast and consistent, it's also adaptable. It can handle all this variation without any problems.
Exactly.
So
Exactly.
it's pretty impressive stuff.
It is. And the test data actually goes even deeper than that. It provides all these interesting insights into how the sentiment scores and embeddings vary across all those different sentences. This kind of information is super valuable for developers because it helps them, fine-tune the module and make it even better.
Oh, okay. So it's not just about showing that it works. It's also about giving you the data to understand how it works.
Exactly.
Yeah, I like that.
Yeah, transparency is so important. And they actually go even further than that to really show their confidence in the results. They've actually included these tests as part of the code itself.
Oh, wow. Okay.
So anyone can run these tests and see for themselves, how well it performs.
That's great. The more transparency, the better, especially with something as powerful as this.
I completely agree. As sentiment analysis becomes more common, more widely used,
Right.
it's so important that people understand how it works, how it's tested. It really builds trust.
Well, this has been really fascinating. It's amazing to see how this module, this sentiment scores,
Yeah.
is really pushing the boundaries of what's possible with sentiment analysis. It's so powerful, so well designed. I can definitely see it being super useful for anyone who needs to analyze sentiment.
Absolutely. And this is really just the beginning. As these models continue to improve, as the algorithms get more sophisticated,
Yeah.
the possibilities for understanding and interacting with language are going to be incredible.
It makes you wonder where this is all going.
Yeah.
What's the future of sentiment analysis? How's it going to change how we communicate, how we understand the world?
Right. How we interact with technology. It's a really exciting time.
It really is. Well, thanks for joining us for this deep dive, and until next time, keep exploring.